So hello everyone, welcome to this new session. So in the last session we have derived one important formula for time response specification, okay, for a second order underdamped system. So in this session we are going to do some of the very important derivations, that is for peak time, peak overshoot, rise time and settling time. Okay, we have four very important derivations here. So now without any further delay, let's get started. So the first derivation is for derivation of peak time. Okay, so what is this peak time, or we can call it as TP. So now let's start deriving this TP, peak time. So first thing, write the output response equation which we have derived, that is C of t is equal to 1 minus e to the power minus zeta omega nt divided by square root of 1 minus zeta square, okay, sine omega dt, sine of omega dt plus theta, okay. So now what we need to be knowing is that at t is equal to Tp, the C of t or the output response would be reaching its maximum state, okay. So therefore we can say that C of t would be maximum. So now according to this maximum theorem, what we can say that the derivative of dt with the derivative of the output response with respect to time, where the time is equal to the peak time here, that is equal to 0, okay, according to maximum theorem. So now without any further ado, let's according to this maximum theorem, let's so go on solving. That is, let's take the derivative of this C of t. So after the derivation, what we are getting is the expression is minus e to the power minus, so derivation of 1 is 0, so that term would be getting neglected. So the remaining terms are minus e to the power minus zeta omega nt into minus zeta omega n, that is the coefficient of t here, minus zeta omega n, sine of omega dt plus theta divided by square root of 1 minus zeta square, okay, minus, so here we are using the UV rule, okay, e to the power minus zeta omega nt divided by square root of 1 minus zeta square into omega d cos of omega dt plus theta, okay. So why I have read, so again in this case I have taken the UV rule for this term, okay, that is first term into the differentiation of second term, or differentiation of first term into second term minus first term into differentiation of second term, that is, so here the differentiation of first term I have taken into the second term minus first term into the differentiation of second term, that is sine omega dt plus theta, okay. Sine omega dt plus theta differentiation of sine is cos omega dt plus theta, and the coefficient of t, that is omega d, I have written it first, okay. So now in this equation what we need to do is substitute the value of omega d is equal to omega n into square root of 1 minus zeta square, okay. So now what we would be getting, so minus into minus is plus, so let's write that first, zeta omega n into e to the power minus zeta omega n t, okay, divided by square root of 1 minus zeta square into sine omega dt plus theta minus e to the power minus zeta omega nt divided by square root of 1 minus zeta square. So now in place of omega d, we need to be substituting it as omega n into square root of 1 minus zeta square, okay, into cos of omega dt plus theta, okay, that is equal to 0, okay. Since the derivative of this C of t is equal to 0, so don't forget to write this equal to 0 sign. So therefore, so now what we can see is we can take this term outside constant, okay. In these two terms we can see that omega n into e to the power minus zeta omega nt, that is e to the power minus zeta omega nt into omega n, we can take it common outside, that is omega n into e to the power minus zeta omega nt. Also we can take this square root of 1 minus zeta square common, and the remaining terms are zeta sine omega dt plus theta minus square root of 1 minus zeta square cos of omega dt plus theta equal to 0. So again we can see that these two terms are getting multiplied, so and the answer is we are getting it as 0. So we can say that from these two terms any one of the term is equal to 0. But here in this case we have omega n in this term, so we know that we can say that since omega n cannot be equal to 0, since the omega n is called as the natural frequency of oscillations. Okay, if there is no frequency of oscillations, there is no response created, so that's why we can say that this term is not equal to 0. So definitely this term would be equal to 0, that is zeta sine omega dt plus theta minus square root of 1 minus zeta square cos of omega dt plus theta is equal to 0. Okay, so now we can simplify this, that is zeta sine omega dt plus theta is equal to square root of 1 minus zeta square cos omega dt plus theta. Okay, I have just taken this term to the other side. So now what we can do is we can write sine of omega dt plus theta divided by this term I have taken, I am bringing it to the other side, that is cos of omega dt plus theta is equal to, in this side we have square root of 1 minus zeta square, and this zeta I am bringing it to the other side, so that is equal to divided by zeta. Okay, so now what we would be getting, sine by cos is tan, so tan of omega dt plus theta is equal to square root of 1 minus zeta square divided by zeta. Okay, so this is the relation which we are getting. But we have one more relation for this term if you observe carefully, that is we know that tan theta is equal to square root of 1 minus zeta square divided by zeta, right? So in the previous derivation for output response we have seen one relation, right? Tan theta is equal to square root of 1 minus zeta square divided by zeta. So what we need to do is we need to be equating these two terms, that is, so after equating those two terms what we are getting, tan theta is equal to tan of omega dt plus theta, right? So this is one more relation which we are obtaining. Okay, from this relation only we have one more trigonometric formula, right? We know that from a trigonometric identity we would be obtaining one relation, that is tan of n pi plus theta equals to tan theta. Okay, this is one identity which you need to be knowing. So here if we compare this equation and this equation, what we can see, in place of n pi we have omega dt. Okay, so that's why we can equate those two terms. Therefore we can say that omega dt is equal to n pi. Okay, where the value of n lies from goes from 1 to 3 up to infinity. Okay, and also we have taken initially the value of t is equal to tp, so therefore we can say that omega d tp is equal to n pi. Okay, but the value of n we should be taking it as 1 because we are doing the derivation of first overshoot. Okay, the derivation of tp at first overshoot, so that's why we need to be taking the value of n is equal to 1. So now what we are getting, omega d tp is equal to, the value of n is 1, so pi, so therefore the value of tp we are getting it as pi by omega d. Okay, so in this way we are deriving the expression for tp, that is peak time. So the final answer which we are getting is tp is equal to pi by omega d seconds. Okay, so this was the derivation of peak time. So now let's see next see the derivation of peak overshoot MP. Okay, so now let's see the derivation of peak overshoot MP. Okay, so now from this figure we can see that here this is the set amplitude, we are taken it as 1. Okay, and here this is the range of MP. Okay, so from this figure we can say that MP is equal to C of TP. Okay, C of TP minus 1, that is C of TP means, so since this is the value of TP, okay, so this whole thing would be C of TP minus 1. So the whole C of TP minus 1, we are getting the value of MP. Okay, yeah, so this is complete C of TP. Okay, and this is 1. Okay, so if we take the subtraction of this and this, if we do the subtraction, only this region would be remaining, that is called as MP. Okay, peak overshoot. So now so we have got this condition. So now according to this condition, let's substitute the value, that is MP is equal to C of TP, or C of T, where the value of T is equal to TP. So substitute the value of C of T, that is 1 minus e to the power minus zeta omega n. In place of T we need to be writing it as TP now. Okay, since T equal to TP, square root of 1 minus zeta square sine of omega dt plus theta minus 1. Okay, so we can say that 1 minus 1 is 0, so we can cancel it out. So MP is equal to minus e to the power minus zeta omega n TP divided by square root of 1 minus zeta square sine omega d. In place of T we need to be substituting it as TP, omega d TP plus theta. Okay, so here we know that we have this, just now we have derived the relation for TP, right? So TP is equal to pi by omega d, right? So just now we have derived it. So now in this equation again substitute the value of TP as omega pi by omega d. So minus e to the power minus zeta omega n TP, here you keep it as it is, divided by square root of 1 minus zeta square sine of omega d into pi by omega d in place of TP plus theta. So your omega d would be getting cancelled. So final expression of MP, what we are getting, minus e to the power minus zeta omega n TP divided by square root of 1 minus zeta square into sine of pi plus theta. Okay, so this is one expression here, but we have one more trigonometric identity if you observe here, that is sine of pi plus theta. Sine of pi plus theta is generally equal to sine theta according to a trigonometric identity. So now in place of sine of pi plus theta, substitute it as sine theta. So now this is the expression here we are getting. Okay, so now please note this expression and take this expression as equation 1. Okay, so now let's further derive it. So now we know that we have one relation, that is tan theta is equal to square root of 1 minus zeta square divided by zeta, right? But in generally, if we draw a right angle triangle, okay, where this is the angle theta, okay, so in generally what is tan theta? It is opposite by adjacent, right? So now in place of opposite side, what we are having, square root of 1 minus zeta square. So write it here, square root of 1 minus zeta square, and adjacent side is zeta. Okay, so the remaining side is the hypotenuse. So now take that hypotenuse as 1 since it's not given. Okay, so now from this tan theta and from the equation 1 which we have taken, that is here we have sin theta, right? We have obtained sin theta, right? So now in place of sin theta we can write here it as, we can write it here as, since sin theta is equal to opposite by hypotenuse, right? So now what we can write, opposite side we have, that is square root of 1 minus zeta square, and hypotenuse, since it's not mentioned, we can take it as 1. So from this relation we can obtain the value of sin theta, that is square root of 1 minus zeta square. Okay, so now substitute this value of sin theta in equation 1. So now equation 1 would be MP is equal to e to the power minus zeta omega n TP divided by square root of 1 minus zeta square. Now in place of sin theta, substitute square root of 1 minus zeta square, so that we can cancel these two out. Okay, so the remaining term is MP is equal to e to the power minus zeta omega n Tp, okay. And also we have the relation of zeta omega and Tp is equal to e to the power minus zeta omega n into pi by omega d, right? And also e to the power minus zeta omega n into pi by omega d is what? Omega n into square root of 1 minus zeta square, right? So here we can cancel omega n and omega n. So our final expression for MP, we are getting it as e to the power minus pi into zeta divided by square root of 1 minus zeta square. So this is our expression which we are getting it for peak overshoot. And also if you want to calculate the percentage of peak overshoot, what we need to be doing, e to the power minus pi zeta divided by square root of 1 minus zeta square into 100, okay. In this way you can calculate the percentage of peak overshoot in case if they ask in the problem, okay. So this was the derivation of peak overshoot or MP, okay. So now let's see the derivations of rise time and settling time, okay. So here the next derivation is derivation of TR, okay, that is rise time, okay. So now here in this plot we can see that this is the rise time here, okay. This region is called as the rise time. So here this is the rise time TR, where it is going above the given level, that is given unit step, that is it is going above 1. So where it, in which point it's going above 1, that point from the origin we can say that it's the point of TR, okay. Yeah, so for derivation of TR, again what we need to be taking is the output response C of t we need to be taking at t is equal to TR, okay, that is equal to 1. Since the TR is till its range is only from here to here, so we can say that from 0 to 1, so we can directly write the value of C of t is equal to 1, where the value of t is equal to TR. So again now substitute the value of C of t, that is 1 minus e to the power zeta omega n t, in place of t substitute it as TR divided by square root of 1 minus zeta square into sine omega d TR plus theta is equal to 1, okay. So now again this 1 and 1 we can cancel, or we can take this 1 to other side, so that would be 1 minus 1, so here we would be getting 0, that is minus e to the power zeta omega n TR divided by square root of 1 minus zeta square sine omega d TR plus theta is equal to 0, okay. So this equation would be getting satisfied when sine omega d TR is equal to 0, since these two terms are getting multiplied again, okay. So that's why any one of the terms should be equal to 0, but here in this case e to the power zeta omega n we have here, but this omega n is not equal to 0, right, since it is the natural frequency of oscillation. So that's why this term should be equal to 0, so that's why sine omega d TR equal to 0, okay. Sine omega d TR plus theta is equal to 0. But in generally we can say that we have one more trigonometric identity, that is sine n pi, okay. Sine of n pi is equal to 0, okay, where the value of n goes from 1 to up to infinity, okay. Now always the value of sine n pi is equal to 0, but in place of n pi we have omega d TR plus theta, so that is omega d TR plus theta is equal to n pi, but here the value of n is equal to 1, since we are considering for the first overshoot, that is the first response we are considering, so that's why we can take the value of n as 1. So therefore omega d TR plus theta is equal to pi, so therefore the value of TR we are getting it as pi. So this plus theta, if you take it to other side, it would be minus theta divided by omega t. So this is our expression for rise time, that is pi minus theta divided by omega d. So this was all about the derivation of TR. So now let's discuss one more derivation, that is derivation of settling time. So this is the last derivation, that is derivation of the settling time, okay. So now what is this settling time? So according to the definition, let's consider plus or minus 2% of tolerance band, okay. And the settling time here is the output, it reaches the, it goes above the level of given amplitude, and it goes down, comes down, down, and it becomes constant. And the area where it becomes constant, that point, from the point origin, the distance is called as the settling time, okay. So now again consider plus or minus 2% of tolerance band. So therefore C of t is equal to 1 in general, but we are taking tolerance band as plus or minus 2%, so that's why we should minus 1 divided by 1 minus 2%, so that's why 0.02. Okay, so that is 0.98. So therefore our value is C of t is equal to 0.98 at t is equal to ts. But at t is equal to ts, the transient oscillation term vanishes. Okay, that is the omega n term which carries the natural frequency, that term vanishes. So that's why our final response, that is C of t at t is equal to ts, is equal to 1 minus e to the power minus zeta omega n ts, where the divided by square root of 1 minus zeta square and sine omega dt plus theta, that is transient oscillation term, that gets vanished. Okay, we would be living with only with this term, that is 1 minus e to the power minus zeta omega n ts. Okay, so again substitute the value of C of t. Just now we have taken it after taking the tolerance error, that is 0.98. so 1 minus e to the power minus zeta omega n ts, so that is equal to 1 minus 0.98, so e to the power minus zeta omega n ts is equal to 0.02. So now take this e to the power the e to the other side, so we would be left with only this term, that is zeta omega n ts is equal to ln of 0.02. ln of 0.02 is minus 3.912, you can check it in the calculator. Then again minus would be getting cancelled, so our ts is equal to 3.912 divided by zeta omega n, or in generally if we approximate, we can write it as ts is equal to 4 by zeta omega n, approximately. Okay, approximately equal to, for plus or minus 2% of tolerance. Okay, so it depends upon the tolerance only, the expression of ts. So similarly, if we take for example the plus or minus 5% of tolerance, so what we can see, C of t value, it would be 0.95, and again the whole different value we would be getting after doing all the derivation. Okay, so if we take plus or minus 5% of tolerance, our answer for settling time would be different, that is 3 divided by zeta omega n. So we can say that with the condition that the settling time varies according to the tolerance band which is given in the question. Okay, so that's why we would be getting different expression for settling time. So that's all for this session. We have seen all the 4 derivations of peak time, peak overshoot, rise time and settling time. Hope you understood these derivations. Please like, share, subscribe, and also refer our playlists, which is where we have solved all the model question paper solutions. It would be appearing on the right of your screen now. Okay, so please go through those playlists and all the model question paper solutions. So that's all. Please like, share, subscribe. Thank you.